Hello YouTube, this is Alexander again. Today the problem was that I have this special suitcase containing CPU, car CPU computer, and so for more handling I put main plug on it, and it's permits to charge the unit inside because there is a little computer with the element which permits the communication with the car CPU, the modem maybe it's called. So I have on this little suitcase this device which is actually the modem, and for the purpose to use this kind of device very easily without getting out all the stuff for charging, looking for a transformer, etc. I put a converter like this to use it with a 12-volt battery. But so I was using a plug coming from a whole charger, and so what I wanted was actually to permit the charge when the suitcase was completely closed. So by this plug you can charge easily your computer and waiting to use it, of course. So for this purpose I found switching power supply, which is stuck here. And the problem comes from the fact that I was searching a plug to fit this one, but actually it's a very special plug, and the main plug was also already used for the DC-DC converter, which permits you to use it in a car with 12-volt batteries. This one fits, but there is no contacts in the center, the center pin. This one fits, but also this is not the good size, and the contact is not good. So I had to manage to make something to make the job, and this is the reason why I put this plug. I use for this, like this part here, I use those pattern here to make a new connector at the size we need. And so this tube copper, you can find this kind of tube copper in a factory when you use a lot of heat on the process to protect it from cold weather. So the goal is to cut a little piece here, of course, to work it a little bit and to make it here with heat insertion with a solder iron. So I did it like that, and it worked very nice. So with 3D printing some copper tube coming from factory, I managed to make this stuff perfectly working. And also what I sometimes need when I make some stuff, banana plug are sometimes like this. You found it like this when you purchase it in a classical market, and you have the plug, the mal is going in there like this, and those kind of stuff are quite expensive. If you are tinkering just for wasting time, for your pleasure, actually, it can be very expensive. Sometimes you need a few of them, like those one, to make your tinkering pragmatic. So I'm also those support was made by 3D printing, and those copper was inserted with the heat coming from a soldering iron, and there is a lot of them which permits to you to make some tinkering when you want. And so when I made this purpose, of course, you need some stuff like this, some tube like this. Also, this is a special tube coming from the industry. connecting some process to special chemical PID. So you need to cut this put it in there. You need to grind a little bit the opening here with a screwdriver, for example. And so this kind of tube helped you to make isolation when you use the central connector, which is very important here, to connect your central pin, actually, which is here. So the central pin used on those kind of connector comes from a computer connector. So you need for this to retrieve it, to recover it, I mean, sorry. And this is how you can recover the central pin for your power plug. It probably comes from a very high-end power supply. So this one goes in a tube like that, a tube like this, with this you have to put your isolated connector, central connector, in there and push it very strong inside until it appears on the other side, and it can give you something like that. And of course you need to grind this stuff for going in there. So in the same thing, those kind of plug are working very nice actually, and very resistant, very solid. The care you need is to solder very quickly before melting the surrounding plastic. So in the same way, you can find this panel from built power supply, not ended of course, and you will have all this banana plug, very not expensive for the occasion, because they are 3D printed and made by copper. Those kind of plug primates can afford a lot of power. Actually, you can take something like 10 or 20 amps from those kind of connector, because copper is very conductive, and this is a kind of very nice quality connecting connector. So also the spring on your central pin is very important to maintain a very nice contact with the female plug, and you can see it's perfectly working for a very low price. So also for this purpose, I was wondering if I can change the temperature set of the 3D printer. So if you look at this video, you will see how to change your temperature abilities, to change your plastic filament, or maybe to experiment with height temperature, what you can do, what you cannot do, if you can increase the speed of your machine. So here you can see I'm printing with a very high temperature, and it can give a very different results. So here you can see it's very smooth and very strong, because the wires are perfectly stuck together. Here during my first test before to make this mod, I noticed then there is 20 degrees missing on my nozzle. So I'm just wondering how it can possible to make some different temperature according the set point and the reality. That means then you will have filaments easily, which can easily clog the nozzle actually. So because I know the PID is made by the information coming from the temperature sensor, the easy way is to change a little bit the value of this NTC, like you can see here, NTC, which means negative temperature coefficient. So here you can see the little pad which need to be cut actually. So it's very hard to proceed on the machine, so I'm requiring 200 ohms resistor on crop parts, and I guess it will be the perfect value at first glance. So the pad is cut now, and you need to solder the little resistor of 200 ohm. This is just the first test. This is not the perfect value you need, because after the test you will understand then the perfect value for that is 60 ohm. So now I'm reaching 250 degrees and I have really 300 degrees on the nozzle, which is too much, because what I wanted exactly is to reach 300 degrees for 260 for the set point. So I put a little potentiometer to adjust correctly and perfectly to not over exceed the maximum temperature. So for 260 degrees I wanted exactly 300 or 280 according the video I made, because I lost a video on this shot. So we are increasing 280 degrees, which is nearly maybe what we can expect from a 60 ohm resistor on in serial with the NTC. Of course, according the different machine you have, you probably need a different resistor. You need to make some experiment with a temperature probe gently to see if you reach the good temperature. You don't need to reach over 300 degrees, because you can damage your printer, and also it's enough for plenty of filament on the market, according to the nylon and other stuff like this, which requires a hot temperature to give a very strong print. So we are very near from 300 degrees. I guess it was my first adjustment, and I want to let it like that. But it was too strong. I need to adjust the potentiometer to make the good value for me. With this kind of very easy modification, you can see the filament is very, very hot, even emitting smoke coming from the nozzle. Of course, I make some control with my finger on the aluminum plate of the nozzle, which is ducted by the fan, and there is absolutely no danger coming from the heat of the nozzle into the cooling fan or the cooling hotend, the bottom part of the nozzle. So you can see the smoke of the nozzle, the proof that is very hot. So it was Alexander again. I hope you like this video, and see you soon.